Hello, good morning to my student. Okay, welcome back to my channel again. So today I want to continue the electron. The Form 5 topics, the chapter, I think there's a chapter 5 already. There's a 5.1. Okay, this one is electrons for the part 2 lah, because part 1 I already is upload there. So the student, hopefully you hear. Good morning, Yiru. Good morning, Zihui. Can listen me or not? Morning, Dandridge. Okay, good morning. Okay, just answer me. You can listen or not? Okay, good morning. Okay, Lisha, morning. Okay, so can listen, Okay, Esther, morning. Okay, so we just continue for this one electron, just only left a short part. Then we go and see what is that. Okay, 5.1, we still electron, but this one is a part 2, Okay, so we go through. Okay, remember cathode ray again for the thermionic emission and also the cathode ray. Okay, now we go through to see. Okay, when the potential difference is applied. Okay, now we got another potential difference. They apply for the cross to the cathode and also anode. So that means the potential difference they apply for the electron to move from the cathode go to the anode. So the electron will gain the electrical potential energy. So this one is a new energy, but this one energy is for the electron. Okay, they gain the electrical potential energy. Okay, remember the potential is the situation when they want to start thing. Okay, they want to start engine to start. Example for the gravitational potential energy. They just like from the very high location, they want prepare to fall down. That one we call gravitational potential. Okay, another one is elastic potential. So that means just like the spring, they were ready to be extend. So that one we call potential. So now we got electrical potential energy. This one is an electron. So that means the electron, they are ready to be accelerate. So this one we call electrical potential energy. So from here, electrical potential energy, the formula should be EV. Okay, E stand for electron, then the V is stand for potential. Okay, now we're going to see the energy will be changes. Okay, when starting sure is the electrical potential energy because you let the electron to accelerate. So number 3, the emission for the electron will gain kinetic energy. When they just got electrical potential energy, they start to accelerate. So accelerate is what energy? There's a kinetic energy. So kinetic energy, the formula should be half mv squared. Then after that, they will accelerate to the maximum velocity. So that means from the cathode to anode, they were moving in very, very high velocity. So last one, the kinetic energy will change to the light and also heat energy when it just hit to the fluorescent screen. So that means the whole process will start from the electrical potential energy. Okay, after that you find it, they will convert to the kinetic energy. So when kinetic energy, the velocity for the electron to move must be very high. Then until the last one, they hit to the screen, they produce the light energy and also the heat energy. So this one is what we go to transfer energy for the cathode ray. Okay, then we go and see the cathode ray. First part sure is a electrical potential energy. So that one is a formula for electrical potential energy. We're using capital E. Okay, electrical energy equal to the electron multiplied with the potential difference. Okay, after that, the heat to the fluorescent screen. So we find it there's a heat and also the light. Okay, then we go through to the uh, transmission. Electrical energy, they'll convert to kinetic. And the last one should be the heat and also the light. Okay, this one is a energy transfer. Okay, now we're going to see the electrical potential energy, E of an electron. Okay, we're going to see how to find the electrical potential energy. Okay, the formula should be capital E. Capital E is a electrical potential energy, then equal to the EV. Okay, electron multiply with the potential. So from here, we're going to see the every physical quantities. E is an electrical potential energy. Small e is stand for charge, electron charge. Then the P is stand for potential difference between the cathode and also anode of the extra high tension power supply. Okay, this one we call it as a potential difference. So the potential difference must be high lah, because it's provided by the extra high tensions. Okay, now we see the charge of the electron is how many? There's a 1.6 times 10 power of negative 19 coulomb. So normally this one question will be provided. Okay, we no need to memorize. Okay, now we're going to see the movement. For the electron, they move from the cathode to anode. So from here, we go to explain. When the EHT power supply just turn on, electron, they will attract. Okay, they will attract, go to the positive charge. There's an anode. So as there are no A molecule surrounding, we don't have any A molecule. There's a vacuum. So the electron, they will accelerate to the anode without any collisions. So without any collision, that means they don't have any energy loss. Okay. So from here, the electron will be achieve maximum velocity. Okay. So maximum velocity later we also need to do the calculations. Okay. By using just now the formula, V is stand for velocity, small v. Capital V is a potential difference. So small v, after that we put max. The minimum, the meaning is a maximum velocity when they are reached to the anode. Okay, so that means when they reach to the anode, we'll convert to another energy. That's a kinetic energy. So from here, we follow the principal conservation of energy. Still remember the word conservation. Conservation means before and after must be equal. Okay, now we're talking about energy. So that means before the electron start to accelerate, and after accelerate, the energy must be the same. Okay, we go to assume we don't have any electron loss. Okay, so from here you can write the equation. Electrical potential energy, straightforward, total equal to the maximum kinetic energy. So from here we can create another formula. EV equal half mv squared. So this one, remember the V, the small v is stand for velocity, and the V will move is very high. So we label that as a maximum velocity. Okay. So from here, E, charge of electron. V is a capital V, potential difference between the cathode and anode. Then the M is mass of the electron. Okay, small v is stand for maximum velocity of the electron. So from here, we got something that's a fixer. For the charge, they're sure it will fix the charge of the electron. Okay, another one should be the mass. The mass of the electron also is a fixed one. Okay, 9.11 times 10 power of negative 31 kilograms. So from here, what we need to find, normally the question want you to find is a potential difference. Then they want you to find the velocity. This one is normally the question they want you to find it. Okay, so from here, we don't waste the time. You straightforward go through the question. And also you need to prepare the calculator. I want to see your answer in the chat room. Okay. So we go through to the first question. Okay, first question. Okay, now the figure they show an electron beam. Okay, there's an accelerate. Okay, accelerate from the cathode to the anode in the vacuum. Okay, the potential difference across the cathode is and also the anode is a 550 volt. So understood, 550 volt is a potential difference. Okay, mass provided, mass of electron, and also charge of the electron provided. Okay, let's see the question. What is the electrical potential energy of the electron? So that means they want to find capital E. Okay, electrical potential energy. So from here, we need to show the info first. Every info you need to drop down. Okay, we got potential difference 550. So this one is a mass of electron, then the electron charge, then the last one we do know electrical potential energy. So I want the answer. Okay, so now you start to do your calculation, then you send to me what is the electrical potential energy for this question. Okay, so anybody? Okay, be careful when you press the calculator because the number is too large. Okay, they got so many power. Okay, don't straightforward go to press your calculator then equal. Okay, we need to step by step. Okay, you equal first, then you bracket, then you get it. Okay, Jia, give me the answer already. 8.8 times 10 power of negative 17 joule. Joule, still joule. Okay, so we go to show. Okay, using this formula, just apply 1.6 times 10 power of negative 19, that's an electron, multiply with the potential difference. So from here we get it. Okay, so then Trish also correct, 8.8 times 10 power of negative 17 joule. Okay, this one should be the answer. Okay, we only got two formula. Depend the question, then you go to modify which one formula you want to use. Okay, we go to continue the question, but now they ask about the B. What is the kinetic energy of an electron when they reach to the anode? Okay, they ask you about kinetic energy. Okay, just now we find it's an electrical potential energy. Okay, now you tell me what is the kinetic energy now? Okay, anybody? For the B, you bracket your answer B. Later, I don't know, you answer me A or B. Okay, so now the question they ask about kinetic energy of the electron when it just reach to the anode. Okay, what do you think about that? Okay, any calculation you need to do? Okay, answer or not? Okay, or you do some calculation, then you show me here. Go or not? Okay, this one is the follow the principle conservation of energy. So just now you say the electrical energy you find already. So the question now they're using another terms to ask you. They say they want kinetic energy. So what is your answer? From here, actually, we cannot find the kinetic energy one because we don't have the velocity. Is it? So from here, follow the principle conservation. So that means they don't have any loss. So we straightforward to write here. Okay, the applying for the principle of conservation of energy, kinetic energy gained by the electron, the same like the electrical potential energy of the electron. So that means we just assume we don't have anything to lose it. So that means finally both energy straightforward go to transfer. So that means 8.8 times 10 power of negative 19 for the electrical energy, you straightforward convert to the kinetic energy. Okay, so this one we no need to do a calculation, we straightforward to write the answer. Okay, there's a 8.8 times 10 power of negative 17 joule, same like the just now answer. Okay, so this one is you understanding or not about the principle. Okay, so we continue with the C. What is the maximum velocity of an electron when they reach to an anode? Now you need to do the calculations. Okay, the question asks about velocity when they just reach to the anode. So the info we still right here. Just now we add one more info. That's electrical potential energy. Now the question they want to find is a velocity maximum. Okay, so what you need to apply? You need to apply this formula. Okay, E capital V equal half mv square maximum. Okay, so from here, I want to wait for your answer. You find for me what's a V. Remember the V you need to square root. Square root. Okay, Yiru get the answer already. Okay, then show me the answer is 1.29 power of 7. Okay, for the velocity. So we go to check. Okay, remember you need to square root. You want to find V max, you need to square root. Okay, EV actually is a E, so we just bring the answer in. 2 multiplied to EV. EV is a 8.8 times 10 power of negative 17. Then you over the mass. Okay, final answer 1.39 power of 7. Okay, times 10 power of 7 ms negative 1. Okay, so this one is how we go to find the velocity by using the electrical potential energy. Okay, I think the students still understand already, is it? Okay, then we continue with question number 2. Okay, in the cathode ray tube, the potential difference between the accelerating anode and also the cathode in vacuum, there's 100 kilovolt. Okay, this one is the first info. Number 2, what is the maximum kinetic energy of the electron? Okay, what is the maximum kinetic energy of the electron? Okay, Lincoln also correct for the just now question. Okay, now they want you to give you the charge of electron and also the mass lah. So what you need to find, you need to find kinetic energy. So kinetic energy from here, actually we cannot straightforward using half mv squared because we don't have velocity. So we just can using the electrical potential energy to replace the kinetic energy. So from here we just write the info. Okay, for the potential difference, we got 100K. So you need to convert kilo. Then after that, electron, mass electron. Then after that, you got charge of the electron. And the last one, you need to find E. E is a electrical potential energy. So that means now you assume electrical potential energy equal to the kinetic energy. Okay, so from here, we need to find the answer for the kinetic energy. So anybody here? Okay, the formula is the same. We just using this formula. Then we can find the electrical potential energy. Then the electrical potential energy the same like the kinetic energy. Okay, so we wait the student to answer it for the electrical potential energy. Remember the energy every time we just write the unit, there's a joule. Okay, we're still waiting for the student. Maybe a little bit slow here. Okay, anybody else? Okay, remember the power. Power got so many power. So that means when you press the calculator, must be careful. Okay, anybody can give the answer here? Yiru can or not? Chayao? Lisa? How about you? Can show the answer here. Okay, I get the answer from Ling Han. Ling Han give me 1.6 power of negative 14 joule. Okay, then the whole dendrich also same. So we go to check. Yiru also same. Lim Zixuan also same. Okay, we're going to show the calculations. 1.6 times 10 power of negative 19. So this one is 100K. So 100,000. So the final answer 1.6 times 10 power of negative 14 then joule. Okay, that's correct. For the 4 students to answer me, that's correct. Okay, then we continue. Okay, continue with the question number 3. In a cathode ray tube, potential difference between the accelerating anode and the cathode, there's a 1022 volt. So this one should be the potential difference. What is the velocity of the electron before they hit the anode? So that means we need to write is an info. Okay, potential difference, mass of electron, charge of electron, and the last one is a velocity maximum. So that means you need to bring the kinetic energy formula. Okay, so we just write the formula first. EV equal half mv squared. Final answer must be square root. Okay, because you only want to find one velocity maximum. Okay, so from here, give some time the student, you can solve the question number 3. Okay, so you just do it for question number 3. Okay, our lesson just only short only for this one. A little bit calculations lah for the electron, for the electrical potential energy and kinetic. Okay, then the next one we go to the 5.2 about the semiconductor. That one is no calculations. Okay, almost is a concept. So the student will be a little bit boring lah about the concept. Okay, so the following after semiconductor, then transistor also the same. Just concept, no calculations. Okay, so from here, EV equal half mv square. Can you find for me the velocity maximum? Okay, so we just wait. Maybe you press the calculator, need some time because the number is quite long. Okay, so the rest, the others, example, Esther can show the answer or not? Okay, Jaya show already. 1.895. Okay, 1.895 times 10 power of 7. Power of 7. Okay, so from here we go to show the calculations. Okay, remember we need to square root. Okay, need to square root. So that means you need to find the E. Okay, you just put the E in. Then the potential difference is 1022. Then you over the mass of electron. Then finally you go to square root. Okay, find all the things first. Then later you go to square root. Okay, we got 3 of the student also get the same answer. So I go to show. Is it the answer correct or not? Okay, yeah, that's a correct. 1.89. Okay, Khadija also give me. Okay, hi, Sabrina is coming already. So the answer is 1.89. Okay, 895, or depends for yours. Power of 7. Okay, power of 7. Then the unit should be ms -1. Okay, this one is a velocity. Okay, so we continue with question number 4. Okay, question number 4. In a cathode ray tube, an electron with the kinetic energy. Okay, now they provide the energy. 1.32 times 10 power of negative 14 joule is accelerated. Okay, need to calculate the potential difference. There's a capital V between the cathode and also the accelerating anode. Okay, info. First one, we know energy. Then we know the electron charge. Then we do know what is the potential difference. This one not velocity. They want potential difference. Okay, I think this one quite easy, is it? Because you don't need to do the calculation for velocity. So the formula we just using, there's a this one. Okay, E equal EV. Okay, although they just say kinetic energy. Okay, but the kinetic energy now we already assume the same like the electron potential energy. Okay, so there's an electrical potential energy, they equal already. So we straightforward take the joule to do the calculations. Okay, any answer from yours? Potential difference. Okay, potential difference. Okay, you just take the energy, then you go to over the electron, so that means you can find the potential difference. Okay, we just wait the student to give me the answer. Okay, the on the line now is Yiru. Then we're going to see the Dandridge, Esther, Ling Han, Jia Yao. Kai Xian. Okay, Kai Xian, give me the answer. Okay, Mei Ling also give me the answer. Okay, 82,500 joule. Joule? Are you sure this one joule? Ling Han give me volt. Yeah, the answer should be volt. Okay, because they find potential difference. Okay, so we just show, I also don't know I write correct or not, volt. 5.25 power of 4. So that means behind we got how many? 1, 2, 3, 4. Yeah, 20. Okay, that's a 82,500 then volt. Okay, remember the unit is a volt. Okay, Zihui. Okay, and also Khatijah, we just write the unit is a volt. Okay, because they want to find potential difference. Okay, then we go to question number 5. Okay, in a vacuum, the cathode ray is produced and accelerated through the potential difference. Okay, potential difference is provided 2.5 K. Okay, now first one, they call you to calculate the initial electron potential energy of the cathode ray. So that means they want to find E because they want to say electrical potential energy. So we just show the info. 2.5 kilovolt, then electron, then the mass of electron, then energy. They want to find energy. Okay, formula again, E equal electron multiply potential difference. So you give me the answer for capital E is how many? Okay, just simple. Okay, we straightforwarded the electron, go to multiply the potential difference, so that means we can get the answer. Okay, so we're going to check the student, how many is here that give the answer is correct. Okay. Many students disappear already. Last time I got see Nixon, I got see Sharon, but today is nothing. Sharon also not here. Sharon, if you here, can you give the answer? Okay, Adrian sure is not here one. After that we got Gary, Kayus, Lim Jirong, Leonard also not here. Okay, anybody can get the answer straightforward, you just pop in. Okay, then I can see your name. Then after that I pin your name go up. So I got proof. That means you attend the class. Okay, any answer? For this one, energy, electrical potential energy. Okay, give me 4 times 10 power of negative 16. Okay, this unit is a joule. Okay, Sikajing here already. Lim Zhisuen. Okay, so the answer is, okay, we just multiply. Final answer, you must have the joule. Okay, 4 times 10 power of negative 16. Okay, so from here you can see who asked me lah, he not in. Okay, Leonard, your mom asked already. Okay, yeah. So I'm going to pin your answer to proof lah. Okay, Leonard is here. Okay. So 4 times 10 power of negative 16. Okay, then we go to the next part. Okay, B. Question B. Okay, question B, they ask about the maximum velocity. Okay, so they want to ask about the V lah. So the info just now we go to add the energy go in already, but now we do know the maximum velocity. Okay, remember we just got another formula. There's a EV equal half mv square. Okay, so from here the student you don't misunderstand. 2V is a different. You don't go to cut. Cannot cut one. Okay, so from here you need to find for me what is the V maximum. Okay, remember square root. Okay, you get E already, so you straightforward put here. No need to multiply again. Okay, just now you get the electrical potential energy already. You just put here. Then you go to settle by the velocity maximum. Okay, after that you just show here what is your answer. Okay, from here they already pop out already. You got one of the exercise you need to do in the GC. Okay, I already upload one is a PPT question. So better you go and do. After that you need to turn in. Okay, another one sure is a Google form lah. Later I will tell you what you need to do. Okay, how about this question? velocity. Okay, velocity. Okay, anybody can get the answer? Remember, velocity, the unit is how many? Okay, later you need to show about the velocity answer. Okay. Leonard suddenly come out already. So Leonard can continue to answer this question. Okay. Okay, we're still waiting. Later you just write and everybody is together upload one. Okay. Maybe the link one they want to together. Okay. Kai Xian can answer or not? Okay, the number quite big. Remember, multiply all the thing after the square root. Okay, I just show the formula become like this. Okay, Kai Xian get it? 2.98 times 10 power negative 7. Okay, Esther also same. Okay, we go to chat. Okay. Okay, we put all the things in. 2 multiply this one 4 we get from the energy. Then divide by the mass of the electron. Okay, then trick also same. So from here the answer 2.98 power of 7. Okay, how come Kaisen got V? There's a ms negative 1. Excuse me, ms negative 1. This one is a velocity unit. Okay, not V. V is a potential difference. So this one is a kinetic energy. Okay, how come the dendrich they got negative 7? They got negative 7. The power of 7. No negative 7. It's power of 7. Okay, ms negative 1. Okay, Jiawei correct. Okay, so this one is the answer. Esther also put negative 7. Negative 7 wrong already. Okay, then we go to the number 6. Okay, number 6 is if the potential difference between the cathode and also the anode for the CRO is a 3.5 kilovolt. Calculate the maximum speed. Maximum speed means V maximum of the electron which hit the screen. Okay, now we see the info. Okay, potential difference 3.5 kilovolt, electron and also the mass of electron, and the last one they want speed maximum. Okay, we're still using the same formula for the just now. Okay, you need to square root. So I want your answer. Okay, so we just wait for the student to do this question. Okay, who's one the fast one? That means you can straightforward to type here. Mei Ling or you say Lim Zixuan, if you just get it, so you just pin here. Okay, you type here, then I straightforward to upload your answer. Okay, anybody else? Okay, a bit calculations. Okay, remember the unit again. Now they want to find is velocity. Okay, so the unit for the velocity, hopefully you remember. Okay, Calvin Yi, long time never see already, Calvin Yi. Okay, Calvin Yi, give me the answer is 3.53. Okay, 3.53. Then after that, power of 7. Okay, power of 7. Okay, the rest also give the same answer. Esther also same. So power of 7. Okay, so this one is the velocity. Normally the velocity power is a positive one because they move very fast. Okay, how come the power is negative? Negative means very slow already. So remember, when you do the calculation for the velocity, the power must be positive. Okay, so positive means the electron they move very, very fast. Okay, so this one should be the answer for number 6. Okay, so the lesson should be finished for the electrons. So today what you need to do, first one, you need to do the formative practice from the textbook. Okay, 5.1. Okay, after that you need to do is a Google Classroom. I already upload the one of the thing, Google Classroom. That's about the electrons. Okay, exercise. You need to finish, then you need to turn in. Okay, after that, you need to key in the Google form for today attendance. Okay, they got some of the question there to test you about the electron, and also got calculation like today, they want the electrical potential energy. Okay, the student will ask what is the code. Okay, today lesson we got code lah. So anybody just help me to type there, electron, capital letter electron, no S. Okay, just type capital letter electron, after that underscore, okay, phi S2. Okay, Jia say cannot access the link. Okay, later I go to settle. So you just go to Google form first. Electron, electron, capital letter underscore phi S2. Yeah, correct. Okay, Khatija already put in. Okay, so this one is what I want to share to you for the Google Classroom. Remember to write your Google Classroom. That one is your attendance, and also I will drop down for your marks. Okay, how many questions? That means you correct how many? That one also is a marks for your PBD. Okay, so from here we just finish lah for today's topics. So you need to go through to do your homework and also the exercise. Okay, everyone, we just finished here. Okay, the next lesson should be the next Tuesday. Okay, everyone, just bye.